Welcome to the S&T College of Engineering, Yavla. In today's lecture, we see some examples on the partial differentiation. So, see the first one. If u is equal to mx plus ny and v is equal to nx minus my, where m and n are the constant, then find the value of w by x suffix y. Next, y by v suffix x, x by u suffix v, and v by y suffix u. Here, these partial derivative in which the suffixes are nothing but the variable are treated as a constant. So, to find the value of this partial derivatives and these terms, the multiplication of these four partial derivatives, first we write the given function u is equal to mx plus ny and v is equal to nx minus my. So here u is a function of x and y, so we easily find the partial derivative of u with respect to x and with respect to y. Second one, y is a function. To find the next derivative, which is this one, y by v suffix x, we have required y is a function of v and x. Next, to find the x by y suffix v, we required x is a function of u and v. And fourth, to find the fourth derivative v by y, treating u as a constant, so we required v as a function of y and u. So to find this four partial derivative, first the first derivative u by x suffix y, that is the variable y is treating as a constant. So the partial derivative of u with respect to x treating y as a constant, which is equal to m. We already given u is equal to the mx plus ny. So we easily differentiate u partially with respect to x by treating y as a constant. So next, to find the next derivative, we required y is a function of v and x. So for that we rearrange the terms. So v is equal to nx minus my. So we shift the terms minus my towards the LHS side. So what we get, my is equal to nx minus v. When we write this equation for the value of y as y is equal to n upon m into x minus v upon m. So we differentiate this equation with respect to v. So we get y by v by creating x as a constant. So we get the partial derivative, which is minus 1 upon m. We denote this one as second. To find the next derivative, we require to solve the two given function u x and two given function equation 1 and equation 2 simultaneously. So we get, by performing equation second multiplied by m plus equation number 1 multiplied by m and equation number second multiplied by n gives nu is equal to m into n into x plus n square y minus mv is equal to mn into x minus m square y. So by solving this equation for the value of v, so we get v is equal to n upon m into u minus n square plus m square divided by m into y. We have to eliminate here x, since we required v as a function of u and y. So here we find the partial derivative kappa v by kappa y by treating u as a constant. So here the derivative we get minus n square plus n square upon n. So fourth one, so to find the fourth derivative we required x is a function of u and v. So for that we eliminate the y variable. So to eliminate the y, we perform equation 1 multiplied by 1 multiplied by m plus equation second multiplied by n gives m into u is equal to m square x plus m into n into y. By equation second multiplied by n gives n into v is equal to n square x minus mn y. If we take addition of these two, so we get mu plus nv is equal to m square x plus n square x. These two terms are get cancelled. So therefore by simplification we get x as m upon m square plus n square into u plus n upon m square plus n square into v. So the partial derivative delta x by delta u treating v as a constant, we get m upon m square plus n square. Now to find multiplication, that is product of these four partial derivative, so consider the product of four partial derivative first, and we substitute all these partial derivative here. By cancelling the terms we get the value of this product of these four partial derivative, which is equal to 1. So in this way we find the value of this partial derivative.